see there are two hosts speaking enhanced IGRP. They're both in the autonomous system 1, so they're part of one routing infrastructure. The first thing I have to do is participate in this enhanced IGRP autonomous system. So I have to send out hello packages again, and both router will perform some kind of handshake with my program. You see in the background, okay, there is a new enhanced IGRP neighbor showing up, which is my notebook, and you also see there are routing information delivered by the two routers. So now I have to choose, either I want to inject an internal route or I want to inject an external route. I will just do the same as the demo before. So I will configure an internal route which just points to my notebook, which is this IP address. I also decide to take /16 network, and my destination again is the 10.0 network. So I will inject this route into both routers, so I have just to mark them and afterwards sending out those updates. So you see one of the routers instantly repeat that routing information to my system. And if we have a look on the routing table, oh, that's the wrong one, sorry. So if we take a look on the routing table, you see there is a new route showing up to the 10.0/16 network. So we also successfully injected some fails routing information into that routing process. So again, all traffic to the 10/16 network will be redirected or routed to my host. And I can do whatever I want with that traffic. Okay. So back to Rene and the next demo description.
Okay, so we are just walking through demonstrations now. There are some routing protocols, like OSPF has a feature like that. That's because I'm going to tell you about that feature here. Some routing protocols have some authentication features. So there, like for OSPF, there's some shared key, a password you have to know to be able to inject routes, because the routing information will be authenticated. Not a lot of networks are really using that. And if they are using that, there are most likely stuff like HighSecure, Cisco, whatever, because, and also they never change, because if you have, let's say, 200 routers communicating within each other, it would be difficult to change the key everywhere. So if they use routing authentication, it's most likely to be a weak password. I'm pretty much amazed what kind of words people invent for password. Sometimes it's key, then it's community string, pre-shared key, password, whatever. All have the same problems. If they're weak, they are easily breakable. Not that's a really new thing to be able to break, let's say, an MD5 hash or something like that. But as I told you at the beginning, we want the stuff to work. We want to be able to combine different modules, so we can just enable the authentication feature in low-key, and we'll take the packages, try to crack the password based on the word list, and again be able to inject routes. And it's pretty much similar for the different routing protocols. I'd say OSPF is widely deployed. Some also use the authentication. So the next thing we will show you is a demonstration of how we can inject or how we can crack the password or the OSPF authentication key. And after it's cracked, it's the same procedure as in the first OSPF demo to inject the routes. If you have the password, it's no problem anymore. So, Daniel, next part.
So it's the same router again. We will have a look at the configuration first. So I will show you the configuration of the interface I'm going to attach in a second, which is the fast Ethernet 0 on the VLAN 20. And you see I've configured an OSPF message digit authentication on this interface. So every OSPF packet sent out on this interface is authenticated using the secret string secret. So when I try to hook up with Loki to that OSPF routing domain without authentication, my packages will just get dropped. So, okay, I will hook up into that net again. So I will launch Loki and select the third prepared network. After I start listening, or after some seconds, there will show up some new routing protocol, which is the OSPF. And this time you see both hosts use the cryptographic authentication. So I need a password to perform the OSPF handshake with these two hosts. So what I will try now is just to select some word list. I use this one. You can easily guess the password is in there because it's just a demonstration. If I use the brute force here, you will sit here until next week. So I will keep the demo short and I put the right password into the work file. So, but just to show you how it works, I will select one of these hosts, and with my Word file, I just try to, let's say, brute force the MD5 secret. And after a few seconds, there are about 4,000 passwords in that Word file. So after a few seconds, or not even a few seconds, the tool finds the right secret. So you see, okay, it's secret, like you can see in the configuration as well. And with that information, I easily can enter it here and perform the OSPF handshake again. So you will see, okay, the state is changing. The OSPF handshake is on its way, and after a few seconds, I will be in state full, get all the routing information. I will show up as a new router in this routing domain, and also I can easily inject whatever routing information I want to inject.
Yeah.
Okay.
Good. That was one of the features here implemented not in Python for performance reasons. And so you see there are mitigating controls provided by the routing protocol itself. Use authentication to be sure there are no fake routes, whatever. But as you see it in a typical environment, if there is an authentication, it has a weak password, and then it's just a matter of time to brute force it and again be able to play around with the routing information and perform some attacks on that.
Yeah, these attacks can also be performed offline, so you just need to sniff one authenticated packet or one authenticated OSPF packet, and with that one single packet you can perform this attack at home. You don't need to stay connected to the network. You just need that single packet, and afterwards brute forcing against the password, and after some time you will find the right password.
Good. Then let's continue. So we showed you some attacks about for commonly used interior gateway routing protocols, namely OSPF and enhanced IGRP. Even the tool is also able to circumvent several implemented authentication methods, whatever. So the point of us is not just me breaking stuff. So as I told you, the idea behind Loki was to close the gap between theoretical stuff and practical stuff, but not only for the reason so you can break networks, but also for the reason to make them more secure, to make your customers or other people believe that it's a problem, so they fix the stuff and somehow. So let's also have a look at what actually can be done against that kind of attacks. So there's not only a problem, there also should be a solution. And if you select a solution for a problem, you should also always mention about the operational impact it gets. So if it just improves your security a little bit, but operational impact, so you have to do a lot of stuff, it gets really complicated, whatever, then it's maybe not so good idea to implement such a feature. So let's have a look at this stuff. There can be used authentication. We just saw it's crackable, but the amount of time it takes highly depends on the quality of the authentication key, of the quality of the password. So if you use authentication, if you have a protocol supporting authentication and use authentication and have some good password, and also don't forget about the usual things, how to handle passwords, don't write it on somewhere or sell your routers with still the password configured, whatever, and clear them before that, then it can be a pretty secure thing. Yeah, you just have to think about how to implement that. And it's not that hard to implement an authentication on OSPF. It's mainly one configuration line each router to set that kind of password. Within the category of access controls, you can also, with some routing protocols, you can also configure something called static peers. So that's based on an IP address. So I manually set my neighbor routers, and I will not accept any routes from other IP addresses. It's just a manual, like, kind of access list. Okay, these routers can send routing information, other IP addresses don't. So he would not be able to, or the router would not accept routing information from his laptop. In such a scenario, we had to, let's say, DOS one router away so we can use its IP address, then maybe it would still work. For some routing protocols, there's a mechanism called passive interfaces. If you configure an OSPF routing process on a Cisco router, you add your interfaces to the routing process, and the routing process automatically takes the IP addresses from that interface. Okay, I know that network, I will propagate it to my neighbors. And if it's a client network, there's mainly no need to speak OSPF actively on that interface, but there's still a need to activate it because else the network won't be propagated to the neighbors. And that's also one configuration command on a Cisco router to say, okay, this is a passive interface. Propagate the network to the other routers, but don't speak OSPF or the routing protocol on that network. So if someone tries to send routing information over this interface, I just discard it, I don't accept it. So that's also a good measurement to prevent injecting false rules. Of course, you can use isolation mechanisms like using different routing protocols. So if one gets a route injected, it doesn't affect the whole network. But that's one of the features that's not so good for your operation. If you don't have to, if you have to manage one routing protocol, it's one thing. But if you say, okay, I use enhanced IGRP in this part, I use something else in this part, then it gets really complicated. You have to have, your administrators have to have knowledge from each routing protocol, so that's maybe not a good point. So I'll speed up a little bit. What's also not bad is IP-based peer filtering. I can put some other access list, not based on the routing protocol, but based on some firewall rules, access lists and interfaces, stuff like that, to prevent routes coming in from wrong hosts. Or I can just say, okay, I'm route filtering, I'm accepting updates for this or that network, but not for, like he just did it, introducing a new network or something like that. Other things you can do, of course, you could encrypt the stuff using IPsec between routers, but as you can imagine, it would increase the operational stuff needed to operate such a network. And it's more likely you have some availability problems because of some IPsec not working properly, stuff going wrong, and would have been more impact on your availability in your network at all. And another point is visibility, just log stuff like that. So you see if somebody is injecting